Hello, hello. Um, Greetings. Good afternoon. Thank you. Good afternoon. Okay. Greetings. Good afternoon, Kaya. Greetings, Alfred. Good afternoon, Ariana. Good afternoon, Sydney. Good afternoon, Genesis. Okay. All right. Hello, everybody. Today is a very important class. Um, I suspect that you are now seeing a document and a number in the Google Classroom that took me far too long to get to you. In many of your cases, you may be rattled by the number that you see. I totally understand that. Well, hold on. Most of today will be spent trying to reassure you. I have a lot of important things to say about ending this semester. Let me start by saying if you are concerned or worried or angry or scared right now, I am here. I'm here to say I see you. I know you probably are. I'm here to make things better, not worse. Okay. I have a lot of things to say. I sound intense because I am intense right now. Wait, there's more people. I am here to try to make the situation better, not worse. And you definitely are going to want to track what I'm saying this period. And you're probably going to play the recording a couple of times and possibly the recording from the other section as well. I know more people are coming in, so I'm going to pause for a second. Oh, good afternoon. Good afternoon. Just pausing for a second. Okay. Um, okay. Well, no more people. Okay. First of all, you should notice, if you didn't already, that in Google Classroom, your long awaited, overly awaited midterm document and score is there in Google Classroom. In many cases, the score is probably scaring you. I totally get that. Um, I, I'm here to say, please don't suspend negative emotions for a minute. Uh, know that I get it, and know that if you're still with me in this class and you have a goal for success in this class, your goal is quite possibly still quite attainable. I mean, it may be different goals for different people. Um, it took me longer than I wanted to get those back to you. I think you're a very good class. I think you've been working very hard. I think you've been with me. I think physics is hard. And I think also I'm going to change the view on the screen. Hold on a second. And as I learned, like going through those exams and taking, as I learned, struggling myself to get those exams done and seeing that many of you were struggling in the exams, I think in some ways this semester has been harder on me and therefore on you than maybe I realized at certain moments. Like, I mean, obviously I've been sick and I've been sort of trying to act like I'm not sick, but it may have had more of an impact on me and on you than I realized. So I want to acknowledge that and like deal with and take responsibility for that. So I have a number of things to say this period of what we're going to do to try to get as much learning and success as possible from this class with the limited time left and get as high grades as possible with the limited time left. Okay. I still think you're a very strong group, and my whole philosophy and grading system is still what it was at the beginning of the semester, which is I want you to do well. I have a grading system designed so that there is not a limited number of A's or B's or anything like that that can be achieved. And necessarily, whatever the numbers are, whoever gets the best numbers is definitely getting an A, and a bunch of people as well will get an A or an A minus or a B plus or whatever. It's not a competition. Oh, 1 second. I'm sorry. Things are happening. Okay, 1 second also. 1 second. Um, okay, people are coming in. Okay, so let me get to the chase here. I know the numbers were scary to you. If you if and then like a lot of the numbers like in the 70s or 60s, like, and there were very few numbers in the 80s or 90s. So first of all, if you got in the high 70s or something like that, is it still possible for you to get an A? Yes. If you got in the 60s, are you failing the class? No. Do people ever fail the class? Yes. But if you got a number on your exam that looks like failing, like 60s or 50, that does not mean you're failing the class. It's still very possible for you to pass the class. Okay. I could be more specific about that again with you as individuals or in the group. But now let me be more concrete about how you're still going to get a good grade in this class if we work properly this last week. Um, the first thing that's going to happen. Oh, well, first of all, can everybody hear me right now? Are you like, I'm about to tell you what our plan is for the last week for the final exam, which is an adjusted plan in light of this information. We're going to adjust what we would normally do for the final exam. I'm about to explain that right now. You may have to play this video again to get, but first of all, and I'm adjusting it so that we can all end this semester with as much dignity and calmness and confidence and knowledge and high grades and readiness for Physics 204 as possible. So before I go any further, and I'm here to say again, I'm still super believing in you, believing you can do well in this class. Um, I know some of you are right now are scared. I want to reassure you. Definitely, I'm not angry. If anything, I'm like frustrated with myself that maybe I should have taken more into account my own health, whatever. I want to try to take responsibility and help with this. So, so I'm about to explain how your final exam is going to work, which is different from what it might look like in Google Classroom. So first of all, raise your electronic hand if like I have your attention and you're like ready to hear this. Thank you. Awesome. Okay. Awesome. Okay. Thank you. And by the way, those of you who some people did do well on the exam, so if you did think this, still listen to this, but it still applies to you. But like obviously, you don't have to be as at the edge of your seat, I guess. Okay, so here's what's going to happen. Your final exam, which will be due midnight of a week from this Wednesday, like it says in Google Classroom, your final exam will be due uh, the 18th of December. It'll be posted by this Friday, all of that, like it says. But what will it consist of? It will consist of two problems. One of the two problems will be that you will redo whichever problem you did worse on in the midterm, whichever problem you did worse on, you're going to redo for your final exam. Okay, you're going to help each other again, like you did last time. Uh, if you've never formed a group chat or a Discord or anything like that in this class, please do one like now. Like, um, you're welcome. Oh, if your hand is up for a question, definitely ask the question. But if it's just up from before, you can put it down now. I'm not sure. Like, Alfred, do you have a question or is your hand just up from before? Okay, thank you. Sorry. Okay. So listen, you're going to have two problems on your final exam. One of them will be whichever one you did worse on the midterm. You're going to redo it as thoroughly and correctly as possible. Like you have a second chance, in other words. Okay. I don't want you to give up on yourself. I don't want to give up on you. You now have the problem back with feedback in it. Maybe my handwriting's bad, etc. But there's feedback there. You can show each other your problems and like integrate the feedback. Furthermore, I will post my solutions to the midterm. I'm going to post them in Google Classroom momentarily. Now they're not perfect. They're just what I use myself to grade your exams, but I will post them so that like you see the answers and you see examples of how to do things. I'll warn you again, like what well anyway, so I'm gonna post my solutions. You have feedback from me in the exam. You can also try to find any and all old videos from this class from past semesters and scroll around and find anything I've ever said about that exam before and use it. You're going to redo one of your midterm problems as one of your final exam problems. Okay. In some cases, and then I'll tell you what the other problem is in a moment. But let me pause on that for a second. So, first of all, you're going to redo. That's to make you feel better, make me feel better, to feel like we're getting, and also to compensate for the fact that it took me so long to tell you what was wrong with the midterm that I want it not to have been wasted time on your part and all of that. So, so in many cases, the main thing that you first and foremost want to go back and really make sure you understand is how to show all the steps of the five-step method for each and every question, for each and every part of any question that you're solving for the midterm or the final. Now, the truth is that actually a lot of you did a very good job. I'm very grateful. A lot of you did make an effort to like break things down into steps to a large extent, and that's good, and you should keep doing that. But let me be a little bit broader and a little bit more specific and say one main step that you really have to make sure is always there for every single part is step two, WIQ. What is the question? Like you need every single part like after you've drawn the diagram, you can always say C diagram above, C diagram above, but every single part you're going to have to make clear what the question is right there. And then step three, GDP, you've got to explain what the concepts are that we're using in the problem and really explain them like in your words and show how they're going to be applied in the solution and the work that you're going to do in step four. And then finally, circle your final answer in step five. Make your final answer super clear. I know I've said this a million times, and many of you are getting it more and more and have gotten homework. But the reason I'm reminding you right now is in some cases, you have correct answers and stuff like that in your midterm. And in some cases, you'll know for sure what the correct answer is when you see my solutions posted. But when you really want to put your effort into and why things got a little dicey in both of our camps with the midterm is the exam is meant to be a presentation. You're meant to walk me through as clearly and extensively as possible everything that you've learned and understand about how to solve these problems. What I'm really trying to say is you want to make your exam so clear and readable and inviting and neat and clear and readable, that not only do have I don't have to do a lot of thinking, I can just see it there clearly, but also frankly, I can maybe enjoy it or certainly move through it quickly. Like, I'm not blaming anything. I mean, there's 1,000 reasons that I take way too long to do exams, but especially with this, what you want to do is make your document so inviting and so clear that it is as easy as possible for me to go through it and find good, clear physics. That's where, like, step two, what is the question, really comes into play. And then step three, here's the physics that I understand. And then step five, here is the answer to the question that I asked in step two. Like, okay, I'm dragging this out, but I'm saying part of what some of you, I need you to, like, when I'm saying redo the question that you did worse on the other exam, part of, for many of your cases, that may be just me put a lot more effort into like a rough draft and a final draft where everything is really laid out and really easy to follow. Triangles made of vectors with tips and tails, and here's X and here's Y. Like, you are trying to teach me the physics, or you are trying to make a presentation that is as easy for me to follow as possible. I want you to do well in this class. It is still very possible for you to do very well in this class, even if the number that you see on the midterm is a little scary to you. Let me also say the numbers on the first midterm are always scary to everybody. It's the first of 4 exams that you take in 2 semesters of physics. Physics takes some getting used to. I take some getting used to. The first exam number is always a little scary, and everybody's grade in the end of the semester is always better than what that number seems to suggest. That's always true. There's nothing crushingly bad about what any of you did or anything like that. I'm not disappointed or scared for anybody. If I sound intense, it's because I know we have less time for me to reassure you of that than sometimes we do. So I'm here to say, like, even if your number is in the high 70s or something like that, it's still possible to get an A or an A minus in the class. Even if your number is in the 60s or the 50s, it's definitely still possible to pass the class. Like, I mean, those are just like broad statements, but what you want to do is not try to learn a whole bunch of new physics now. You want to get more of a handle on how to present the physics to me in a way that is clear and compelling and convincing. Think of your redo on this problem as an opportunity to represent and repackage and recommunicate. Okay. I'm trying to reassure you right now that I'm still rooting for you and I still believe in you. I'm serious. And I want you to do well. And there will be A's in this class. Like, there will be, even if there were no 90s on, and I'm not even saying that that's the case, but whatever, like, there will be A's in this class. And hopefully there'll be a bunch of them. You're not in competition with each other. And what just happened on this midterm just means that I'm adjusting my approach to what we do on the final, but it doesn't mean that we're adjusting the approach so that you could still do as well as we were ever hoping you were going to do. All right. So first of all, again, especially for people that just joined or whatever, your final exam that will be due next Wednesday night, your final exam will consist of 2 problems. One of them will be a redo of whichever problem you did worse on this exam. You're going to just redo it from I'm just going to write that in the instructions of your final exam document. I'm not going to reprint everything or whatever. It's going to be up to you to go back to whichever problem you did worse and redo the whole thing from scratch. Don't hand me corrections. Like, start it over on blank paper, drag it out, make it bigger, make it clear, skip lines. Like, consider your midterm one of a couple of rough copies that you're doing for a final copy that you're going to turn in on that problem to me. And again, for anybody who just joined, I will post my solutions. That will help. You have feedback from me. That will help. You can watch old videos. That will help. You should help each other. That will help. So one of your 2 problems that you're going to do on your final exam is a redo of whichever one you did worse on the midterm. That's number one. I'm about to tell you the other problem on your final, but I'm gonna pause for a second. And again, please, I know I'm yelling. I know I sound all intense because I am intense because it's that type of year, and I'm I want this to go well for you just like you do, but I'm not angry or anything like that. I'm just being intense. So first of all, is it clear what I'm so far? Is it clear what I'm saying about what one of your problems on the exam is going to be? Great. Thank you, Ariana. Thank you. Thank you, Kaya. Thank you, Cindy. Okay, great. Thank you, other people. Roger, thank you. Okay. Oh, and thank you, Gerard. Oh, and I see the chat. All right, great, great, great. Thank you. Okay. All of you. Like, thank you, Sanam. Thank you, Brandon. Thank you, Erica. Thank you, Joran. Um, all right. Now, what's the other problem on your exam? The other problem is now posted in Google Classroom, like under exams. Under exams in Google Classroom, there's something that says homework 1B. Like, why does it say that? Because that is it's the second part of the first homework that is usually assigned in Physics 204. The first homework that's usually assigned in Physics 204, for the most part, in fact, I'm going to screen share right now so you can be totally clear about this. Hold on one second. Oh, wait, it's not there. Hold on. Hold on. Okay. Okay, you can see this. Okay, so this thing, what this is, and it will be, it's the first problem that's assigned in Physics 204. The whole first page of it, in fact, sorry. Yeah, the first page of it is technically like review. It leaves off, I mean, it starts where in principle we leave off in Physics 203. In other words, the first page of this is ultimately about work and energy, which is the last topic that we've been dealing with in Physics 203, things that would have been on your final anyway. But what we're going to do instead of the final that you would have had, I'm telling you right now that this first homework problem that we usually do 204 is what the other problem on your exam is going to look like. And I'm going to talk about it in a few minutes. I'm going to talk about the physics, and I did in the other recording too that you could play. I'm going to like tell you how to do it conceptually. And I'm not going to change this. I mean, I might change the numbers, but I'm not going to change the questions. Um, what this page is going to be the other problem on your exam. Okay, it's posted in Google Classroom. Now, this is a two-page thing, but I'm telling you right here, this second page where it says challenging but central and all that, to be clear. And again, watch this video later uh if there's any confusion in your mind, but this is totally not on your final exam, okay? That will be relevant next semester when you start 204, but it won't be on your exam here. So to back up and summarize, you're going to do two things on your final exam. One, you're going to redo your weaker portion of the midterm. Two, you're going to basically get a jump start on the first homework of 204 so that between those two things, we can all reassure ourselves. We can all reassure ourselves that your efforts and your patience on your midterm were not wasted. Like, and that whatever temporary disappointment or fear you might be feeling about your midterm will get solved by you and me. You're going to fix that so you feel like your efforts weren't wasted, so that the fact you had to wait this long doesn't then just go into nowhere. You're going to fix, I mean, you're going to redo from scratch your weaker problem on the midterm, and then you're going to do the first part of Physics 204, so that also when we reunite and meet each other for 204, which I'm very much looking forward to, you'll feel like you're starting ahead, not behind. So we'll feel like we accomplished what we needed to in this course to get us ready for that course. Okay, so all of this is meant, even though I sound again very intense right now, all of this is meant to say to you that I still believe in you, that I'm still rooting for you, and your efforts have not been wasted and they've not been unnoticed. And we're going to end up doing fine in this course and being ready for 204. So your final, I'm going to say it one more time, then they're going to pause. Your final will consist of two problems: a redo of whichever you did worse on the midterm, and a pre-do of homework one from Physics 204, like not this page. In other words, in other words, I'm just going to share it again. This part, not this, this is what the other problem on your final will look like. It's in Google Classroom. Okay. I don't know if I'll post answers to this, but I will say also, before I forget, if you go back to any playlist of mine on YouTube from Physics 204 from any semester in the last, all the semesters since COVID, I spent like the first like 50 classes in Physics 204, like walking through this and walking through solutions and everything. So feel free. I mean, and, go to the most recent, like last summer or whatever, last spring, and go from there. But there's 1,000 videos. There's not 1,000. There's many videos where I walk through this whole problem. And so, and I'm going to talk about it for the rest of today once I do, but I will expect you again to not just put answers, but explain in as many words and in many equations and as thoroughly and clearly as possible in the 5-step method. You'll get the answers to questions like 1 through 5. These questions right here that are on the screen right now is what your questions will be on your final exam. I'm going to say one more thing and then make sure this is all clear. Your final exam, despite whatever it looks like in Google Classroom right now, your final exam will consist of the two problems: the your redo of the midterm and this. Last thing I want to say about that is when you do that final exam that you'll turn in by midnight of Wednesday, the 18th, whichever exam you do better on, the final or the midterm, I will count more than the other. Like I do have to count both. I can't throw away an exam. But whichever one you do better on, I will weight more heavily in your average. Okay. And then plus you have all these other points from all the homeworks and all that stuff. And then plus your lab average counts. And again, if anybody wants to, I'm going to put in the chat again, like if you're confused about how the grading system works or how it is that you necessarily will end up with a higher grade than the number that you're seeing on your midterm right now, you will. You will end up with not as a gift, but the way the grading system works is your grade at the end of the semester will be higher than the number you're looking at right now. Now, how much higher? Well, that depends on how much other work you've done and how you do on the final. Like, obviously, I'm not saying everybody automatically gets an A, not at all, but I am saying that there's definitely still time to get a good grade in this class. If you're still confused about how the grading works or whatever, putting again in you can text me and we can talk about your specific situation or whatever. But yes, I will. But whichever exam you do better on, I will wait more. All of this is a long way of saying I still want you to do well, and you still can do well. We do have 1 week to get it to get like you still have to work. If you just stopped right now and didn't do anything or didn't take the final seriously, then some of you it would be a kind of scary situation for some of you. So the ball is still in your court to make this happen. But you give me anything to work with, and I will, and my grading system will work very much with it. And any borderline that any of you is on ever in a micro moment during an exam document or in the macro of your final grade, believe me, if you're on the borderline, you get the benefit of the doubt. Believe me. Um, so please, even though I'm yelling right now or sounding intense, if you are worried, I understand that. I'm here to tell you there's more room for hope and more room for less worry than you think right now. I'm just as invested and concerned and believing in you as I ever was. Okay, so far, there's more to say, but is that clear? I'm going to stop the screen sharing. Hold on a second. Is what I'm saying about the final exam and how it'll be graded and stuff, is this clear so far? Thank you, Ariana. Thank you, Gabriella. Thank you, Brian. Thank you, Yaneli. Thank you, Genesis. Thank you, Sanam. Thank you, Erica. Thank you, Drawn. Okay, thank you for the yes, sir. Okay, okay. Now there's still more to be said, but all right, good, good. And again, if there's any issue, I mean, there was anyway, if there's any issue, put in the chat or whatever. Also, when we're done with this whole class, I'm going to post the video. Of course, I always do, but I'm also going to post the other class video because in both, I'm trying to explain all this, but I'm also trying to explain the last physics to you. So there may be you may benefit from playing both videos to catch any nuance that just, differs from one section to the other. Like I would highly recommend watching both videos just in case. But okay, other logistical matters now. Uh, I told the other class something I'm going to tell you now too. It might be, well, what I told the other class is the other reason I'm being all intense about this right now is, and by the way, again, I think it may be the case that this semester has been a little harder on me and therefore you than I kind of realized. And I apologize for that. That's like part of what this is about. Like, obviously, I have a medical condition. I've sort of been trying to act like that doesn't affect anything, but like maybe it does. I mean, me and you, therefore. So why am I saying that? Well, to that end, and things, and it's gotten harder recently and logistically harder. So why I'm saying all that is this Wednesday, when we technically have the last class of this class, my belief right now is we're not meeting. What are you supposed to do at that time? Like we would meet, but what do I want you to do at that time? A couple of things. One, take a breath, look at this video, look at old videos, catch up, talk to each other, form a group chat, try to fix the problem from your term. In other words, use that time to catch a breath and prepare for the final. Also, though, it's an opportunity to get any last points that you could possibly squeeze from anywhere from this class because it's technically the last class. So any old homeworks or revisions or whatever are due that day. So where's two easy examples for you to get some last points that might help you? Well, number one, if you know how every day, most of you do know this, every class we've had has a game turn, due that night at midnight. Just notice that today, and it's always worth 5 points. They add up. It's not a huge amount of points, but they add up. But tonight's, if you look in Google Classroom, it's worth 15. You still only just have to write like I paid attention to class and I understand the arrangement with the final exam or whatever. But just because I'm as concerned as you, and I want you to have all this clear, tonight's is worth 15 points instead of 5. So do it. Like that's just okay. Like just do tonight's on time. You'll get 15 points instead of 5. But in addition to that, I've noticed that still a lot of you have not done the teacher evaluation. We really care about the teacher evaluations. Am I now panicked about the content of your teacher evaluation? Of course I am. I'm not telling you what to write in there. I will never see what you will write in your teacher or your faculty evaluation. I promise I will never see what you personally write about me personally. What I do see and what I care about is how many come back, like just my numbers, just like the percentage of return. It's important for the school for us to get this data. It will be important for me to improve my teaching next semester to get the data. I will never know who said what, but I need, I beg you to fill them out, even if you're going to fill them out angrily or negatively, like whatever. That's, that's part of it. But so please know you get 20 points in this class for just filling it out, the teacher evaluation. And many of you still haven't. So take I'm not going to take the time now to get to stop in the middle of the class, but Wednesday, we won't have a required class period. Take the 20 minutes or whatever it is to fill out both the lecture section and the recitation section for this class. You could say the exact same thing in both. You could say really angry things if if you need to, but say something. If you fill out both the sections and you screenshot evidence that you filled them out. Now, a lot of you have done this, so I do know it works, but a lot of you still need to do it or can still it's whatever. So if you do both sections and you show a screenshot that you did both, the lecture and the recitation, you'll get 20 points for that. If you do one, you get 10 points. If you are an e-permit student, I always forget about this, but for some reason that I do not understand, we apparently don't have a system for allowing e-permit students to evaluate John Jay faculty. That makes no sense to me any more than it does to you. It doesn't seem right. I would like to change that, but right now it seems like the case. So if you're an e-permit student, you can't, or at least I don't know of a way that you could fill out. Like I know you don't have a John Jay email address, etc. So if you're an e-permit student, you can't fill one out. So if you're an e-permit student, in the portal in the Google Classroom where it says student evaluations, just type in there to me, like in the private comment, just type, I'm an e-permit student, I can't do this. Then I'll know that we're at least that you acknowledge we're in a conversation, that you would have done it. That's good enough, and you'll get the 20 points. Okay. So please, Wednesday morning, use your time to do the evaluation and work with each other to try to prepare for this final exam. It is possible that I may hold, now things keep changing my mind, so I'll let you know if I could possibly hold a Zoom office hours or something like that. I can't promise that. Right now, I just don't think I'm available, but we'll see. But in any event, that's how you should use your time on Wednesday. So here, I'm temporarily, I mean, for the next 37 minutes, I'm going to just try to do physics and just try to help you be as clear for the final as you could possibly be. Um, so we're going to switch. Sorry. So we're going to switch to physics in a moment. But let me catch my breath and say, actually, let me catch my breath. Um, okay, I'm catching my breath. I caught my breath. So I'm going to switch gears to physics in a second if you tell me you're ready. Well, or let me, are you ready? Like, is all this clear? Are you ready for me to like do the last physics here? Thank you. Okay. Thank you, Brian. Thank you. Okay. Awesome. Awesome. Okay. And before I do, let me just say again, I know I'm being all intense. It sort of bothers me how intense I'm being. Oh, okay. But let me say again, this is a temporary like goodbye sign off, or it will be like in 35 minutes. I think you've been a wonderful class. I think it's been a hard semester, maybe harder than we knew. I've loved working with you. I very much look forward to seeing you in 204. I very much hope you have a great holiday. Like when all this is done, when we get through this and you have a great set of holidays. On, uh, uh, I very much look forward to seeing you on the other side in 204. Hopefully, we're going to hit the ground running in 204, like I mentioned before. Also, I look forward to supporting you in your futures. Like if you have ambitions to summer programs or um, or graduate school or the MSBS program at John Jay or lab or trying to be a lab tech or anything like that, please reach out to me. Like, please don't think that I'm like upset or something about these mid. I'm sure you're more worried and upset about these midterm numbers than I am, but I believe that you might be, so I'm trying to deal with that. I would still very much like to support you all in your futures. I look forward to seeing you in your more short-term future with me in 204. That will be after the holidays. Let me also say, I almost forget this. Grades, grades are due to the CUNY first from professors on December 27th, 2 days after Christmas. That's usually the way it goes. So usually what I do, just so that you know, usually, and I will try to do it this year, although maybe a little more challenging. It takes me a while to grade things, as you see. My grades are always at the last minute, but they're always on time. Like the grades are due like 11 p.m. December 27th. That's when they'll be posted to CUNY first by me. Okay, so don't expect to see your grades on CUNY first until like whatever it is, 11 p.m. December 27th. However, what I usually do, and I will try to do this year, usually like a day before that, December 26th or something, I usually post a spreadsheet to everybody, like with the name, whatever. I usually post a sheet to you with all of your grading information, your full calculation with your final exam, like the full breakdown, so that you can see your grade and how it was done and all of that. Usually everybody gets like a spreadsheet with that, like basically 24 hours before grades are posted. So look out for that. So you have like 20 hours to make sure you understand and I didn't make a mistake or something like that. And then I post. So you, unless you hear otherwise, you should probably expect that like the night of the 26th or something, which is odd, but the night of the 26th, you should get a spreadsheet with me with a breakdown of your grade. And so you'll get like a warning before it goes official. Okay, so look out. But okay, so that's how that works. And then again, after we get to the other side, then I'll see you in 204, and hopefully we'll all be more relaxed and we'll see that this all worked out for most of us. You still have to do your part in this last week, and so do I. We have to make this happen. Like you do have to work to make sure you're going to get the grade that you've been looking for, but you still can. Okay. So, and again, I think I already wrote this, but again, if there are issues between now and then, I mean, you can always email, but you can also text. And if we need to have a quick phone call, we'll do that. Okay. So now, with the last 32 minutes, I'm going to put up the screen and try to give you the big picture of the physics that we've been working on. That is our last unit of this semester, and that will help you for the other problem on the final exam. So, bear with me for a second. Okay. So there's a summary of what I need to do right now to help you. And again, everything I'm about to do, I'm going to say somewhat quickly. You want to understand it and say it as extensively as you can in your final exam. And again, I would encourage you to play a bunch of the first videos from jjP204 spring of 24. Like that's a playlist, right? Like look at the first few classes from the spring semester version of 204 or last year's version to really get extensive breakdowns of all of this. But here we go. The idea is to wrap up this final topic of the semester of work and energy, specifically as applied to the concept of a spring, right? So picking up where we were last week, work itself is defined to be the path integral of force. We discussed that last week. Like that's not an easy concept, but it is the concept. In English, work is the accumulated effect of pushing or pulling something through a one-dimensional space. The more newtons that you exert on something through the greater number of meters that you displace that something, the more joules of work you're doing on that thing. So to do work on something is to push it or pull it through a displacement, through space, right? In simplest terms, we could just say work is force times displacement. We could even say we could even say work is force times distance if we're really being simple about it. The reason that the integral comes in, the reason that we're more specific and careful, is we're trying to acknowledge the possibility that a displacement might be big enough or a situation might be complicated enough that the force might change continuously as the object is displaced, right? Like it might not be the same F value every millimeter of the motion. In case the F value is changing as a function of position, we have to take that into account by integrating the force through space. Like that's like the summary of what we were saying last week. So work is the path integral of force. It means the total, the total sum, the continuous sum of all the force displacement products along the way. That's what work is, triple equal sign. Now, why do we care? Like, what does work do? What's the double equal sign here? Like literally, like, fine, work is force acting through a displacement. But why do we care? Well, good question. To find out why we care, let's look at a simple case of let's look at what the impact, let's do some algebra to find out what happens to an object if a bunch of forces are acting on it. In other words, if there's a net force on an object, if there's a force going one way and a force going another way, and you take into account minus signs and you add them all together, once you add up all the forces acting on an object and the object is displaced, through some path, can we do algebra to see what the purpose of all of this is? Okay, well, F net equals MA, right? So F net times displacement, F net times X equals MA times X. That's what I'm saying here. So if I want to know what the net impact of work is on an object, I can look at the MA of the object times the X of the object. Now, I can think of my old equations for A of acceleration from the beginning of the semester. I'm going to think in particular about one equation that we had that didn't come up a lot, but came up sometimes. We had this one equation, A equals V squared minus V naught squared over 2X. That one equation was the one equation that we would ever use when we didn't know anything about the time and we didn't care about the time. Like we weren't solving for time and we didn't know about the time. That's precisely the situation where work is relevant. Work is forced through space. It has nothing to do with time. So I'm going to use that space equation, the equation that relates acceleration to only things in space, nothing in time. And I'm going to substitute in A equals V squared minus V naught squared over 2X. Thus, if I substitute that in, net work on an object, net F times X equals M times V squared minus V naught squared over 2A times X, right? Bottom line on the board. So, okay, so new slide. So I just recopied from the bottom. So net work on an object is M times V squared minus V naught squared over 2X times X. Because we're looking at force. Net force is MA times displacement to make work. So the X's cancel. So you end up having mv squared minus v naught squared all over 2. So you could distribute the 2, you could factor out the 2 that's in the denominator. And algebraically, what this says is that the net work done on an object is mv squared over 2 minus mv naught squared over 2. Like, so what? What does that even mean? I don't know, but I know this. Well, I don't know yet, but I know this. Anytime in physics you have some quantity minus that quantity naught, like the beginning of the semester, x minus x naught, that means final position minus initial position, right? In other words, change in position. How the value of the position changed from some old value to some new. We call that displacement. Or v minus v naught. That's how velocity changed from some initial value, some value of v at time equals 0 to some new value, v now, right? Any quantity minus quantity naught means the change in that quantity from an old value to a new value. So apparently, when you do work on an object, What you change is the object's 1f mv squared. Like, I don't know what that means in English just yet. I'm not even saying you're supposed to, you might recognize 1f mv squared from some other class or high school. That's great if you do, but I'm not saying that you need to. I'm just saying the algebra shows that when you do work on an object, you change the 1f mv squared of that object. What does that mean in English? It means like, look, say you have this object and you're about to start pushing it through a space. If or you do push it through a space, you take some snapshot, some moment. You ask, what's the mass of this object? You ask, let's start again. You ask at some snapshot, what's the instantaneous speed of this object? You square that. You multiply that by the mass of the object. You divide the whole thing by 2. You take that quantity and you write it down somewhere. That quantity, the 1/2 mass times square speed, that will be a number of joules. Why will it be a number of joules? Because a joule is a Newton times a meter. A joule is a unit of force times a unit of displacement. In other words, a joule is a kilogram meter per second squared times a meter, right? A joule is a Newton times a meter. A Newton, a unit of force, is a mass times an acceleration. So a Newton is a kilogram times meter per second squared. Multiply that by a meter, you get kilogram times meter squared divided by second squared. Maybe that's a lot. Maybe you have to replay this video to hear this. What I'm trying to say is the units of newtons times meters are the same as the units of kilograms times v squared, if you think about it. One is kilogram times meter per second squared times meter. The other is kilogram times meter squared divided by second squared. Play it again if you need to. But I am saying, this is what I'm saying. If you start pulling an object through space and you pick some moment and you just freeze frame and you zero in on the object and you take its instantaneous speed and square it, multiply that by its mass and divide by 2, you'll get some number measured in joules. Write that number down, like in your mind. And then you keep pulling and pulling the object till some later moment or later point in its path, as you were pushing or pulling it through, as you were doing work on it through the path. Freeze frame again. Write down what the speed of the object is now. Square it, multiply by the mass, divide by 2. That'll be another number in joules. It'll be a different number. If you compare the two numbers, the amount of joules that the object gained from here to there will be precisely the amount of joules of work that you did on the object. That's what this algebra is saying. I'm not saying I would have known that. I'm not saying that's obviously logical. I'm just saying it's apparently true. I'm saying when you do work on an object, when you push it or pull it through a distance, you change the amount of 1/2 mv squared of the object. The amount of joules by which the 1/2 mv squared of the object changes is precisely the number of joules of work that you did on the object. Therefore, this 1/2 mv squared thing that I never would have cared about before, I never would have thought about it, I never would have come up with it, but the algebra tells me to focus on it, I now focus on it. 1/2 mv squared is the combination of measurements that identifies an object and that seems to track along with the object according to exactly how much work is done to the object. Therefore, so when you do work on an object, you change the amount of 1/2 mv squared of that object. Therefore, we give a special name to 1/2 mv squared. From now on, we call the 1/2 mv squared of an object the object's kinetic energy. We give it a name. I mean, of course, you've heard this before. I know you've heard of energy before, and you may even remember from high school or something that kinetic energy is 1/2 mv squared. What I'm telling you now is like, why? Okay, I'm telling you that 1/2 mv squared is a descriptive set of measurements for an object because it's what gets affected by work, by pushing or pulling the object through space. So from now on, we give it this special name. We call it kinetic energy. From now on, the kinetic energy of an object is the 1/2 mv squared of the object. What does this all mean in English? It means that what work is triple equal sign. What work is triple equal sign is the path integral of force. What work is pushing or pulling something through a distance. That's what work is, triple equal sign. What work does, what we care, why we care about it, what its consequence is, double equal sign, is it changes the 1/2 mv squared of an object. In English, if you push or pull an object through space, you will change the 1/2 mv squared of the object. If you push it and it goes in the direction you're pushing, you're doing if your force and your displacement agree with each other in signs, then you're doing positive work, so you'll give 1/2 mv squared to the object. Where will the 1/2 mv squared come from? It'll come from you. Oh, is that a yes, M. That's an M. Yeah, I'm not, I see in the chat an M. I don't know if that's a, but I agree, I think. Or you could clarify if you want in the chat. But when you do positive work on an object, you give it 1/2 mv squared. Where does it come from? From you. If you do a negative work on an object, you take away 1/2 mv squared from the object. Where does it go? To you. Let me say this in English better. Kinetic energy. What is energy? What is energy? Energy is the ability to do work. Energy is the ability to do work. Specifically, kinetic energy is the ability to do work by virtue of motion. The more motion you have, the more v squared you have, as if you're some m, if you're some mass, the more motion you have, the more the ability you have to do work. What does doing work mean? It means transferring energy. I mean, well, what it means is pushing or pulling through a distance. What does that look like? It looks like a transfer of energy. Does this sound like circular reasoning? Yes, it sounds like circular reasoning, but it actually does mean something. It's just like money. Energy is like money. Work is like a transaction. What do I mean? I mean, money is the ability to perform a transaction. Transaction is the transfer of money. Why do I want a lot of money? Because I want the ability to spend. I want a lot of money because the more money I have, the more I can spend it. That sounds odd. It would be just total nonsense if it weren't for the fact that I could spend money on things that have equal value but come in different forms, right? If I have $100, I'm happy I have $100 because eventually I can get rid of that $100 and exchange it for $100 worth of Pokemon cards, right? Like in principle, nothing's happened. I gave someone else $100 and they gave me Pokemon cards, same value, right? But I'm happy that I had the $100. Why? Because I could give up the $100. Same thing with energy. Energy is the ability to give up energy to something else. Why would you ever want to do that? Because it's going to convert from one form to another, maybe from kinetic to potential, maybe from kinetic to thermal, whatever it is. If in English, one last time, then I'm going to move on. If you have energy, you have the ability to do work. If you do work, you transfer energy. What that looks like in English is if you are big and moving fast, you have a lot of energy. So what? So you can crash into something else. If you're big and moving fast, if you have a lot of 1/2 mv squared, you can exert a force on something else and push it through a distance. If you have a lot of 1/2 mv squared, you can fx some other m. If you have a lot of kinetic energy, you can exert a force on something else and move it through a distance. You could do work on it. When you do that, if you do it positively, you will speed up the other object. You will give it 1/2 mv squared. You'll give exactly a number of joules that you just did worth of work. And where do those joules come from? They come from you. You will slow down. right? So energy is a commodity that we pass around through the transaction known as work. I'm going to say it one last time and move on. Energy is the ability to do work. Work is the transfer of energy. Work is pushing or pulling something through a distance. When you do that, you speed up or slow something down according to, in effect, this double equal sign right here. Like the path integral of force equals the change in 1/2 mv squared. The work that one system does on another equals the amount of kinetic energy one system gives or takes away from another. Okay, that's the significance of work. We have 13 minutes left. In that problem that you're going to do for your final exam, you'll see, and again, you're going to do like the first page of that problem, not the second page. You'll see that the main point ultimately it's asking is we put some mass on a spring and we let the mass go. And so the spring pulls the mass in to a certain spot known as the equilibrium position. The spring exerts a force on the mass and pulls it in. So the spring does work on the mass to bring it in. Your ultimate job in that problem is to find out how fast the mass is going by the time it gets pulled in. So you're applying this reasoning to the problem that you're going to do for the final exam. You'll figure out the work that's done by the spring to move the mass a certain space, and the work that the spring does will yield the change in kinetic energy of the mass. From the change in kinetic energy, you'll solve for V. And that's like the goal of the problem. So the only thing left that you need to hear from me is like, how does this concept apply specifically to springs? Like, why is it a spring that we're talking about? What does that have to do with anything? Good question. So this is the last bit to discuss in these 12 minutes. Well, okay, so here's a summary of what I just said in English. Kinetic energy is the ability to do work by virtue of motion, and work is the transfer of energy. That's what I was just saying over and over. Okay, so now how does this relate to springs? Well, remember that work is the integral of force with respect to displacement. It doesn't need to be an integral. If force never changed, if force were always a constant value throughout some displacement, we would just say work is force times displacement. It's an integral to take into account the possibility that force changes continuously as a mass travels from one place to another. So a spring is exactly this type of situation. A spring is an object that exerts a force that varies as a function of x. A spring force is not one constant number. A spring force gets stronger and stronger as one edge of a spring is pulled farther and farther away from the equilibrium position. Specifically, Hooke's law for a spring says F equals negative kx. For any spring of stiffness k, k stands for the stiffness of a spring. How strong a spring is. The higher the number k, the stronger, the stiffer the spring. K will be a number like in the hundreds, like 200 or 300 or 400, but it's measured in newtons per meter. K is a number measured in newtons per meter. It's how many newtons of force the spring exerts per every meter that the edge of the spring is displaced away from its natural resting equilibrium position. So imagine like the problem that's your final exam problem. Imagine that you have a spring. One edge of the spring is attached to a wall. The other edge of the spring is like free to move, right? If you just attach a edge of a spring to a wall and you let the other just like sit there dangling, where it will naturally come to rest, we call the equilibrium position, and we'll label it in our minds x equals 0. You can imagine attaching a mass to that edge, and the mass is just sitting. and this could be on a floor, so like it could be on a lab tabletop or something. So wherever the edge of the spring naturally just sits by itself, we call the equilibrium position, we call x equals 0. If you try to hold the mass out to the right of the equilibrium position, you'll feel a tug from the spring. The spring will try to pull the mass back toward equilibrium. It will exert a force on it. If you pull the mass to the right, the spring is going to pull to the left. Hence the negative sign in this force expression. If you push the spring to the left, if you try to compress it, the spring will try to yank the mass back the other way to the equilibrium. So the spring always tries to restore the mass back to its equilibrium position. But so that's what the negative sign is. But the thing is, the reason we make mattresses out of springs or gym equipment out of springs, what it means for springs to be elastic is that if you ever thought about if you are at the equilibrium position, the spring doesn't do anything at all. If X is 0, the F exerted by the spring is 0. It's perfectly happy. But the farther away you get from the equilibrium, the harder the spring fights to bring you back. That's why, like, you do exercises and gym things with it, because it's harder to hold a spring out here than it is here. The force exerted by the spring is directly proportional to the displacement of the spring edge from equilibrium. It's like a straight line graph. If you were to make a graph of X versus F, you get a straight line, and the slope, well, really, you'd get a negative straight line, and the slope would be K. So we look at spring. Spring is the first example we ever look at where the force is not a constant number, it's a constant change. It's not a horizontal line, but it is a straight line. The force exerted by a spring is directly proportional to the spring's displacement from equilibrium. Like that's like literally that's Hooke's law written right here. But that's like the definition of what it means to be elastic. That the elasticity tries harder and harder to snap back in proportion to how far unsnapped it is. So it's a perfect example of a kind of force that we need integrals in order to calculate the work. In order to calculate the work done by a spring, now I'm just doing it once right here on the board. You don't have to do it over, like you'll show this, you'll do out this reasoning in your final exam, but it is this reasoning. Like you don't have to do a different integral, it's this integral. The work done by a spring to bring the spring in from position x naught back to equilibrium, position 0, would be the integral of that force, negative kx dx, right? I'm just plugging in negative kx for the F and saying, and also I'm noticing, and in the case of a spring, the force is perfectly parallel to the displacement. So all that stuff about dot products and everything, like you still have to know and all that, but in this case, the angle is 0, so the cosine is 1. So you can explain that in the final, but and you should, but you won't get into any fancy cosines or sines. Like the cosine will be 1, so that the vector symbols will go away, and you'll be left integrating negative kx dx. What's the integral of negative kx dx? Well, the negative k comes out, it's a constant. So you have the integral, and I'm doing this fast. I mean, you practice on your own or you explain it, but negative k is a constant, it comes out of the integral. So you have the integral of x dx. What's the integral? What's the antiderivative of x? You do the derivative backwards. You do the product, the power rule backwards, and you get x squared over 2, right? But then you have this negative sign there, but to get rid of the negative sign, you flip the limits of integration. Again, I'm saying this fast, but think it through or practice or think about it at home, and you'll see that the work done by a spring to get a mass from position x naught to position 0 would be 1/2 k x squared. That would be the work done by the spring. So what? So in general, the work done by a spring, I can even say like this, if it makes it more clear. Hold on. The work done by a spring to move something from one position to another, the work done by a spring will change the kinetic energy of the mass at the end of the spring from one value to another. So if you're looking at that problem right now that I'm saying is going to be your final exam, this is what you would use to solve when it asks you ultimately how fast is the thing going, is the mass going by the time it gets back to the equilibrium position. How do you solve that? You do the work done by the spring must equal the change in the kinetic energy, and you solve for V. Now, again, there's tons of videos on this to explain it in many, many more steps and make it more clear. And I don't want to fool you. Like what I'm looking for on your final exam in both of your problems is I want you to explain, like, don't just write an answer or don't just write an equation. Do all the steps, explain it as thoroughly as possible. But this is the thing to explain that when you're solving for the change in speed for a mass on a spring, you need to do the work done by the spring. The work done by the spring is the integral of the spring force times displacement. That's what you'll do to solve that problem that's on your final exam. Now, like we're done. I mean, we have like 2 minutes left. I honestly believe that as far as math or equations or facts, these are all the facts you need to rock your final exam. So the good news is it's you know exactly what's going to be on it now. Like you're looking at the problem and you know what the other problem is. There's no surprises, and I'm rooting for you. I'm with you. That's like the good news. Like the bad news is, right, you still have to do all of this, of course, in the next week. And I am saying that part of what sort of went awry for some of us on the midterm is you have to go overboard to explain stuff. I'm not asking you to do lots of crazy math or lots of details or anything like that. But the details I'm asking you to do, I'm asking you to make as clear and thorough and clear and thorough and clear as possible. You can work with each other a ton. And please do make a group chat or whatever, but then produce a document that I want to read and that I don't have to look at anything else, that I don't have to like kill myself to read, and that I can read enjoyably but quickly. That's your goal. Many of you will still get A's or A minuses or whatever in this class. Those of you who have been struggling and are suddenly worrying about passing, you're still in shooting range for a B or a B minus or a C. Like everybody's in a higher shooting range than you probably think, but you still have to make the final shots. You have to aim and fire in this last week. If whatever work you give me, I will maximize its outcome on your grade as much as I possibly can without doing anything unfairly, treating one person any different from another. But the system is here designed to optimize all of your performances based on you doing your part and working. So that's all I have to say. Um, and I'm much more optimistic and excited than my looks like right now. But I think you've been a terrific group, and I'm good if you're good. So unless I won't see you Wednesday. Um, Text me anytime or whatever. And have a great next week and a great holiday. I'm going to stop the recording. I'm going to hang out here for a second if there's any questions or anything like that. But